Hello, class. New week, new chemistry topic. Although I'm probably jumping ahead to some of the material, we're going to talk about acids and bases later in the course. But why not? I saw this article and I'm like, oh, students will probably like this, and it's for the next issue of Chemical Engineering News. And I know it's still January, but welcome to the future. And here are some acids you can put on your face. So, what is an acid? Again, you'll learn more about it later. Generally speaking, an acid is something that puts positive charge on something. Or you can look at it as an acid takes away electron density. So a base is something that adds negative charge or gives electron density to something. So acids, they suck up electron density, or you could look at it as adding positive charge to something. So, okay, and some common things that we use, you've probably heard of alpha hydroxy acid. So here's some organic chemistry. I know we haven't gone over Lewis structures yet, but right here, this is a carbon atom, double bonded to an oxygen, single bonded to a oxygen, which is bonded to a hydrogen. So, and then here's the next carbon in this corner here. So, this next carbon is the alpha spot, and then this is the alpha hydroxy acid. So, in salicylic acid here, so this is a beta hydroxy. Here's the carboxylic acid group. So that's the carboxylic acid group. I know this is organic chemistry. We haven't we're not really doing organic chemistry this semester. But here is a carboxylic acid group, and here's another carbon. Here's another carbon. So this is the alpha spot. This is the beta spot, and then the OH. So as I'm using some of these terms, you might start to think, oh, I've heard these things before. So a common drug is GHB, which is gamma hydroxybutyric acid. So that's butyric acid with the hydroxyl group on the gamma spot. So alpha, beta, gamma. So, right. So anyways, the way that, so what's the point of putting these things on your skin? What they do, so they're generally speaking exfoliants, and you can see there's many other things here that they can do. The layers of skin, you have your epidermis, which is filled with keratinized skin cells. And then you go further down into your dermal layers. And some people say, well, the surface of your skin, it's dead. Kind of sort. I mean, yeah, it's not living anymore. That your skin cells, they go through a process called keratinization. And keratin is a protein. It's an interesting protein. It's almost exclusively alpha helices as a secondary structure. So hair, I don't have too much hair. Maybe I'll use my eyebrows, I guess. Hair, skin, and fingernails. It's all keratin. It's all the same protein. And so you got to think of that though. With cosmetic chemistry, I know if you're using things like hair straighteners or permanent waves, they're breaking the hair bonds. If it does it to your hair, it'll do it to your skin. So be very careful when you're using these. So again, we're jumping ahead for a lot of things. Glycolic acid is water soluble. Salicylic acid is more fat soluble or lipophilic. So this sits in your skin a little bit longer. It goes into the fatty tissues. This is it goes in the water. Generally speaking, things tend to be either water soluble or fat soluble. And that's not a hard rule, but it's a general rule. Alcohol, ethyl alcohol, for instance, is both. But generally speaking, compounds tend to fit in one or the other. Here is ascorbic acid, also known as vitamin C. Funny how ascorbic acid, it's anti-scurvy acid. So I found out, if you eat this acid, you don't get scurvy. We'll call it anti-scurvy acid. How about ascorbic acid? Yeah, that's fewer letters. I like it. So ascorbic acid, anti-scurvy acid. And this is the primary antioxidant for the body. It's water soluble. And we have fat soluble antioxidants too. Vitamin E, for instance, is a very common fat soluble antioxidant. But this is also known as a reducing agent. How does vitamin C work? Like, well, imagine I have a bunch of hungry college students and I have a big plate full of Brussels sprouts. And like, I really want to protect my Brussels sprouts. I don't want my hungry college students to come and eat all my Brussels sprouts. What am I going to do? I'm going to go and I'm going to order a bunch of pizzas. So I'm going to put a bunch of pizzas and stick it right in front of the Brussels sprouts. And the hungry college students are going to come and they're going to eat all the pizza and they're going to be stuffed and they're not going to touch my precious Brussels sprouts. So how do I defend my cell's DNA against very reactive molecules like radicals? I don't want my DNA to be damaged, so what do? I've got vitamin C there. Free radicals go, ooh, vitamin C, and they gobble it up, and the vitamin C is gone, but my DNA is safe. So that's the same. In the analogy, obviously, I'm comparing Brussels sprouts to like a cell's DNA. So that's the idea with the ascorbic acid. Is it's a reactive reducing agent, and it goes and it helps take away very reactive molecules. So these are newer molecules here. So lactobionic acid. So polyhydroxy. Poly means many. So hydroxy, and you can see all these OHs. Well, this is a carboxylic acid group here, but you can see there's just OHs all over. Oh, and right here, this is actually an ester. So you're going to have an ester linkage. Ether. Ether. This is an ether. Oh, and here's another ether right there. So you have two ethers in this as well, not just the carboxylic acid here. And here, this is not even a carboxylic acid. This is a ketone. So this right here is a ketone. It's also got an ether right here. So you can learn about these. This is not on the class, not a part of the class. You're not being tested on any of this, but this is just some organic chemistry that you can learn later. And you can see here what it does. And I've been hearing things about hyaluronic acid. So it's kind of one of the new things. It's a polysaccharide. So saccharide is sugar. It's a many sugar. So I've never seen a sugar with a nitrogen in it though. So that's interesting. But here and this N means number of units. So this is many, many units here. So this is a newer one. And what is a humectant? You can see this word humectant. Humectant means that it draws water to things. So a common humectant that we use is glycerin. Glycerin is also a humectant. So if you see glycerin in like soaps, that's what it does. Is it draws water to it. I mean, I know glycerin is used for other things like it's how we store our fats, or as in triglycerides, but its functionality in products like personal care products is a humectant. Means it brings water to it. So and of course it has other things here. Retinoic acid. So retinol is vitamin A, and it's retinol. It's an alcohol. Alcohol just means OH. So if you get rid of the double bond O in this, that's retinol. That's vitamin A. Of course, retinol for your eyes. We use it in our eyes. And you might be familiar also with beta carotene. That's just it's double this. It's pro-vitamin A. Your body takes beta carotene and turns it into vitamin A. So that's one thing that's interesting is that retinol is actually toxic in high concentrations, but beta carotene is not. You can eat all the beta carotene you want, and you won't get a toxic dose. But retinol, you can get a toxic dose from that. So well, it's not really a vitamin. It's a vitamin derivative. I'm looking at the vitamin word, but you can see it does various things here. And lactic and citric acids, these are alpha hydroxy acids here. Yeah, it's various things. Chelate, if you wonder what a chelate is, exfoliant, this means it just takes skin off. So chelate means claw. So it takes, so if you have so soap scum is usually calcium, magnesium stearates or fats. So it's a precipitate. It's a precipitate, and it reacts and it forms on the edge of your shower or bathtub, and you can get rid of them by using a chelating agent, a claw. So you have the calcium or magnesium ion, and this molecule, you can see citric acid is kind of a big floppy molecule. It kind of goes and it grabs around the ion, then it pulls the ion into solution and then dissolves the soap scum. So I've used citric acid to clean my shower before. It works really well. It does work really well. So it's a decent chelating agent. Very common chelating agents also EDTA. You've seen EDTA. That's ethylene diamine acetate. So, but anyways, that's getting all excited talking about chemistry and the and ingredients. So these are acids you can put on your skin, and here is a scientist, Michelle Wong, and talking about these, and this is kind of what they do. So if you're like personal care products and into this, you might be interested in this article. But part of it is chemistry is more than just the stuff you learn in your books. So chemistry, we use it quite a bit. So that's one thing about chemistry that's so useful. And I like this article. Part of it. I also I was an intern for Intimate Brands, which is that's Bath and Body Works and Victoria's Secret. That's a company called Intimate Brands, and they have the bath and fragrance side. And I worked with them as an intern for 3 summers. My father, he worked there, so he with privilege I got the job. So I learned a lot about some of the chemistry of personal care products. So, but yeah, so I hope you like the article, and I hope it's you find it interesting. Sorry if I talked a little bit more today. I know I should talk less, and one thing about teachers is that we like to talk. So if you ever go to a meeting and you have the choice to go to a meeting with teachers or with administrators, especially, or clerical staff, go to the meeting with administrators, not with one of the teachers, because teachers will talk and talk and talk. So I guess we like hearing ourselves talk, just like me right now. So aren't you happy to hear me talk? But all right, I'll stop here. I hope you liked the article. I hope you learned some stuff. I wanted to give you a little background on what the molecules mean, though. And it's a preview also for future stuff in this class and future chemistry classes if you go on and take more organic chemistry. And like I said, hope it gives you some context to the class and to what you're putting on your face if you're using these products. Another point. I'm very mindful of your time. There was a problem with problem set 4. One of the answers had, in my opinion, was a mistake, and a student brought it to my attention, and I looked at it, and yeah, there was a mistake. So I gave everybody credit for that specific problem. So if you see your problem set 4 suddenly has work done, that's just me giving you full credit. So because, like I said, I value your time. Your time is precious, and I want to make sure that your time is optimized. And I don't see you investing your time into something that is not done properly. So why should I do that, right? I mean, but I strive for excellence. Hopefully, you strive for excellence, and I apologize that specific problem was faulty, and now it is no longer a concern for you. So, okay, well, as with all my messages, I hope you are well. If you find yourself not feeling well, like if you need help with your basic needs, if you're dealing with crippling mental health problems, if you have academic issues, other than this class, of course. I mean, teaching this class is my primary responsibility. Uh, or something else, feel free to reach out. I'll do what I can to help. And I hope you have a nice rest of your week. So, goodbye for now.